Buenos dias, fuckers. Buenos dias. Well, hoy no tenemos sol, so there's no sun today. So we're going to read a little bit from the Book of Popular Science from 1961. I think it's relevant. It's only about 86 pages. Not really, but we're going to about 4 or 5 of these. The birth of the earth. You know, stuff. 1961. This is where it all started, folks. And then we'll go over a bit of this afternoon, see how we go with this. The gravity and magnetism, how they're not alike, how they're nothing alike, how they're just absolutely nothing alike. So north is that way. So this is for your entertainment purposes there, while I read. Just don't hit the side. All right, look, just hit the side then, because it slows down. Friction, like the water under the Bering Sea, that shallow sea. All right, folks. Now, how the Earth was born, how it all begun, theories for how it all begun. I think it's good. The early human inhabitants of this planet thought that the Earth was flat. Silly, isn't it? Thinking it was flat. God, it's a terrible start. It seemed to stand still with the sun, moon and planets moving around it. The same as it does now. The sky, as far as they could tell, was all above them. How could they have guessed that the Earth is a huge ball rotating as it travels around the sun through the sky? How could they have guessed that the sky stretches in all directions away from the Earth, below it as well as above it? How would they have known that back in those days, eh? Of the universe and the Earth, early man knew only the tiny bit he saw around him near home. In the very early days, he had, of course, no means of travelling except on his own 2 feet. A man could live his whole life in a narrow valley, never guessing that anything lay beyond. His horizons were more narrow and limited than we can imagine. No, I can imagine that with those 2 feet, he went walkabout. No means of travelling. A man could live his whole life in a narrow valley, never guessing that anything lay beyond. 1961. 1961. Right? I might not be able to get through this. A man could live his whole life in a narrow valley, no means of travelling except on his own 2 feet. Has anybody been out of here? No, Grandpa. You've stayed here since I was born. No one's been anywhere out of this valley. But it's only 100 feet. You're not going anywhere, Grandpa. You've only got 2 feet. We're stuck in the narrow valley for all eternity. Oh, maybe this was a bad idea. Maybe, just maybe. As time went on, legends and myths grew up about the Earth and the manner in which it is supported in space. Some early peoples believed that it floated on a great sea of water and that the sun, during the night, swam from west to east through that sea to get back to its rising place in the east. The early Egyptians thought that the universe consisted mainly of Egypt, which shaped like a shoebox. The sky was a metal ceiling through which the gods let down lamps at night, the stars, to make the sky more beautiful for man. I thought Egypt was a little bit of rub-a-dub hub. I thought it was a bit, chic, that people were coming in and out with the camels and the rocks and people with money and robes and children for sale and all that kind of stuff. Gold, satin, pearls. Was it not a hustle and bustle? But here it says, Egypt thought that the universe, consisting mainly of Egypt, was shaped like a shoebox. So maybe they didn't go to different places. 1961. So the story changed with the times, how they change. This might have been a bad idea. Do you not get the feeling? I get the feeling, which is why I'm saying this, that this stuff, 1961, I've read it in the 1950s. Nothing really about this stuff. But in 1960s, end of 1950s, 1960s, bang, we have, here's your history. Okay, learn it, yes, learn it. Okay, this is what happened. This is what happened. All of them, 1600, 1700, speed of light, the motions of the planets, everything, wasn't it? But it all came neatly packaged. Like, here you go, giddy up. This is your history. Read it, digest it. This is what happened. It's feels like our parents, maybe their parents, they just fell off of a calendar and they were here, not knowing what's going on. And we've just been winging it ever since, and now somebody's hustled us. That's what it feels like to me. That's what it feels like to me. All of this, so much, all of these 1600s, right? So much info. Like, it had never been mentioned to anybody before, but we're going to tell all of you lot now. Everybody else the last couple of centuries missed it because it was quiet on that front. So we have all of these people that discovered all of these things about 300-400 years ago. But like I said, it went dead quiet, no science. It just died. And then now look, we're getting back to space, and we just clicked on these guys back in the 1650s, 1600s. So luckily, they worked out everything that we need to go, up. It's all there. Luckily, somebody remembered. Because if they hadn't remembered this stuff, what would they have done in the 1960s? How would they have explained, all the stuff they were doing? It was lucky, the Kepler, the Galileo, the Newton. A myth is what Newton is. This could have been a bad idea, folks. Look, that's just for entertainment purposes only. All right, let's do this. Hang in there with me. It's bound to get better. It's going to make sense soon. The sun was a god who rode in a celestial boat around the ramparts of the world, disappearing at night behind the great mountains that rimmed the edge of the earth. At one period, the Hindus imagined the earth borne by a huge elephant which stood on the back of a gigantic tortoise, swimming in a sea of milk. A variation of this universe idea was that there were under the earth 4 foundations. The earth was upheld by 4 elephants, supported on the back of the great tortoise. The tortoise himself rested upon a gigantic world serpent, coiled upon itself. Wow. And floating on the cosmic waters. What supported the waters was always something of a mystery, however, and the subject of much discussion. But let's not worry about the 4 elephants supported on the back of a great tortoise. The tortoise himself rested upon a gigantic world serpent, coiled upon itself and floating on the cosmic waters. What supported the waters was always something of a mystery. However, and the subject of much discussion. Elephants? No. The water, the serpent, the tortoise? No, the water. What? This stuff. Already. In the days of ancient Greece, although most people still believed that the earth was flat and the center of the universe, there were a few scientists who were in advance of their time. Now, what is this saying? It's saying that loads of people still thought that, it was flat. But luckily, there were some scientists that were ahead of their time. This is the art of making people presume. It's the art of making people presume. Now, anybody who takes this and reads it and thinks, it's a fact, all of it, they'll go, scientists ahead of their time. Here we go. Now they're going to bring our scientists out into the light. Science. If you ever argue, you have a discussion with a scientist, you're just wrong. Okay? That's it. You're wrong. Science does not care about your common sense. And the universe does not have to make any sense to you whatsoever. So just enjoy the ride. Believe the horseradish that we will feed you relentlessly. Right. The Earth was flat and the center of the universe. There were a few scientists who were in advance of their time. They felt sure that the Earth was round and that the stars were faraway heavenly bodies, perhaps like our sun. They had no way of proving this, of course, for the telescope was not invented until the beginning of the 17th century. Many of the ancients believed that the sun, the moon, and the planets with the stars beyond moved around the Earth on a great crystal sphere. The turning of these spheres was believed to produce beautiful, though inaudible, celestial music. Beautiful, but inaudible. You know what that means? They can't hear it. So it was beautiful, but couldn't hear it, music. This is the kind of thing I'm saying. It's the turning of these spheres was believed to produce beautiful, though inaudible, celestial music. So if it's inaudible, this music was called the music of the spheres and was the conception of Pythagoras, a Greek scientist who was born in 580 BC. So this is, a good few centuries before the top guy comes down, before the top dog, el numero uno. In the 2nd century AD, there lived in Alexandria a great scientist, mathematician, astronomer, and geographer, because astronomers, anything in those days, they were chippies, plumbers, bakers. They weren't like nowadays. They just do one thing and not very well. Like you might get an astrophysicist that just puts a lot of his own spin on things. Facts are kind of, you'd have to go out of your way to find the actual fact sometimes. But these guys back in the day, jacks of all trades, right? Not just one. Jacks of all trades. They don't make them like they used to, obviously. Now, his name was Claudius Ptolemy. He is usually known as Ptolemy. Ptolemy wrote a great book, the Almagest, from the Arabic words meaning great system, in which he gathered together the astronomical ideas of the early Greeks. He not only explained these ideas, but added some of his own. For many hundreds of years, Ptolemy's ideas about the solar system were accepted without question by scientists. That must have been very tough for the scientists. It's probably because there weren't any about. That's why. He taught, as so many others had before him, that the Earth was the fixed centre of the universe around which all the other heavenly bodies revolved in circles. Ptolemy, however, observed that the planets did not appear actually to move as simply as that. To account for what he observed, that sometimes the planets seemed to move to the east and sometimes to the west, he invented a system of epicycles. If you will look at the diagram on this page, you will understand what epicycles are. All right, you should have that by now. Epicycles. So it's like one wheel sits on another wheel and turns, different ways depending on the wind and stuff. Look, all you need to know is they're epicycles, okay? If you will look at the diagram on this page, you will understand what epicycles are. Small circles moving around a larger circle with their centres on the circumference of the larger circle. This was a very complicated idea and in time was proved to be quite incorrect. It was accepted, however, for many centuries. Accepted because nobody was about. So he invented this thing, thought of it, but there was nobody. So he was like it went on for a few centuries and then no talk of any science, nothing. But they just so happened to have a notebook somewhere and, oh look, this guy in such and such a year. Oh, okay, well no, I think he's wrong there. How long ago was this? 300 years ago. That kind of a thing. So, to be believed? I am going to struggle. Sorry for my smugness, my facetiousness, Simon Dan would say. I'm not being facetious, Simon Dan, you know that. It's up facing north. Gravity. That's magnetism, by the way. I know the difference. Right, where are we? We've done that, Ptolemy. Right. The Arabs were foremost in the study of astronomy in the Middle Ages. Everybody had a go. Just comes in spurts, you know. Oh, we found this. Oh, wow. Boop, that's it, 200 years. But somebody managed to get all of the info. Somewhere, somebody had written little scrap notes. They passed it down. And then, poof, these people hear it. They put it all together. It's ever so good. It's ever such good reading. It really is. Right. During the next 1,000 years or so, there was little progress in astronomy. The Arabs, who were very accurate observers, left many records of what they saw in the sky during that period. Stars and the moon. Stars and the moon. Stars and the moon. A couple of planets. They built during those centuries many observatories and devised many useful astronomical instruments. About 1610, one of the most important scientific events of all time occurred. Buckle up, Dorothy, okay? The story goes that the children of a spectacle maker in Holland were playing with some of their father's lenses one day. They discovered that by combining them in a certain way, they could make far objects appear to be close by. This discovery was the beginning of the telescope, which was very shortly to be used to such great advantage by the Italian astronomer Galileo Galilei, known to most folk and by his close friends, Galileo. Holland, spectacle maker, his children. Papa, Papa, look! And then Papa, what? Oh, I've been making these lenses for 30 years, kids, yeah? Yeah, 32, Papa. And you just, well done, kids, because how did I miss this? All I had to do of all these years, just put two lenses together and I would have seen some kind of aberration somewhere, you know, that would suggest, it's going to be okay. When astronomers began to peer out into the sky through the wonderful new instrument, they came to realize in time that the planets, the stars, the moon and the sun were enormous balls, spherical heavenly bodies. Then the students of the sky began to wonder about the Earth. Was it too a heavenly body? Could it possibly be a planet like Mars and Venus? What was it like in the beginning and where did it come from? For some of the answers, astronomy called upon geology. The Earth has not always been as it is today, and in fact we can even now watch the surface of our planet changing. Over the years, we can in the short span of one lifetime see shorelines changing, glaciers dwindling, mountains levelling off, and islands upheaving from the deep valleys of the oceans. We watch ice and snow at their work, tornado and sea, earthquake and volcano slowly recarving the face of our planet. And we worry about man-made climate change. Is that 1 degree per century? Or is it spiked to 1.5 degrees per century? Upheaving from the deep valleys of the oceans, we watch ice and snow at their work, tornado and sea, earthquake and volcano slowly recarving the face of our planet. It's getting a bit warm. Can we do something? Geology teaches us that such changes have been going on for longer ages than we can measure. We find the remains of ferny tropical forests amid the ice of the Arctic and the Antarctic. We discover the signature of glaciers on the rocks of hills and woodlands. Upon the heights of mountaintops, we come upon seashells, selling cockles and mussels alive. That is not seashells. In the very beginning, what was the earth like? In what great heaven-shaking event did its birth take place? No one knows the certain answer to these questions, but many scientists have thought long and hard about it. Since the beginning of the 19th century, many theories have been suggested to account not only for the birth of the Earth, but for the birth of the whole solar system as well. For of one thing we are certain, with the Earth were born the other members of the Sun's family. So, how do you know that? Whoever wrote this, how do you know the Earth was born at the same time as the other planets? How? It's a ridiculous notion. Not that they form together, but to say that we definitely know. It's irresponsible, it's reckless. It's truly compelling. Not only those people who knew nothing whatsoever about science, but most of the astronomers also, before the time of Nicholas Copernicus, believed that the Earth was the centre of the universe. It stood still in the sky, so they thought while the other heavenly bodies moved around it. Copernicus, a Polish monk, was sure. There's a lot of monks involved in this kind of stuff, isn't there? Always. Where are we? Sorry. A Polish monk was sure that this idea of the solar system and of the universe was all wrong. He believed that the sun was the centre of the solar system and that the planets, the children of the sun, moved around it in an orderly path called orbits. So he already had orbits. What are you going to call that again? Orbits. Okay. So that's where that came from, called orbits. It came with the planets, that word. Copernicus wrote a long and very important book in Latin, giving his reasons and such proofs as he could muster for this belief. So obviously, everybody back in those days spoke Latin, because he wrote it in Latin, so everybody obviously spoke Latin. Genius. While there were some astronomers who agreed with Copernicus, it was a long time before his theory was generally accepted. It was a religious conviction with many people that God had created the Earth as the centre of all that existed in the universe. To deny this was to them a dreadful heresy. In time, however, Copernicus's idea about the sun and its family came to be accepted under the name of the Copernican system. The work of Galileo did a great deal to prove that Copernicus had the right idea about the solar system. With his telescope, Galileo discovered, for one thing, that the planet Venus passes through phases, just as Copernicus had predicted. Here we go, the boys are at it. Just as he had predicted. Oh, well done, Galileo. Copernicus said that. I know. They always do that. Well done, Galileo. Wouldn't expect anything less, though, not from Galileo. Galileo discovered also that there were 4 large moons moving around the planet Jupiter. In brackets, his telescope was not powerful enough to show any of the other 7 Jovian moons. 1961. So in the 2026, we would write in the 1961 episode, they didn't have telescopes powerful enough to detect the other 90 moons, at least. This proved that there were at least some heavenly bodies that did not move around the Earth as their centre. Galileo's discoveries were, of course, the first stepping stones towards actual proof that all the planets move around the sun instead of around the Earth. Galileo, could you go and get Newton and come and meet me behind the shed, please? Can you not see a little bit of a pattern emerging here? It's so obvious. Galileo. We haven't even brought Newton up yet, I don't think, have we? Even after Galileo's observations had proved that the Earth is not the centre of the universe, people were most unwilling to give up their old ideas. In fact, Galileo was convicted of heresy by the Inquisition and sentenced to prison, though the sentence was never carried out. He was forced to remain in seclusion for the rest of his life, however. Oh, lucky Galileo. Good effort, though. In time, Copernicus' work was proved to be correct in its main points, largely through the work of the German astronomer, Johannes Kepler. Now, ding ding, we're all getting off here. Next stop, we're going to sit down and listen to what happened next with Kepi. No, I'm joking. Well, to the end. Yeah, thank you. basing his theories on data collected by Tycho Brahe, a Danish astronomer, Kepler formulated 3 laws of planetary motion. Just like that. Well done, Kepi. Basing his theories on... one of them states that the planets do move around the sun. Now listen, Kepi, it was one of Kepler's laws. The planets move around the sun. Boom. It is case closed. We're locking and we are throwing away the key, aren't we? Because we presume that this is correct, don't we? We presume that there was this back and forth, that it was flat for so long. And then these people that, for me, seems like a little bit of fiction, come out of nowhere. They're on this board, I have to get this down again. They just appeared, a gang of them, all over Europe. It's like they were all the same DNA and they just were born and started doing shit. By the time they were 10, they were teachers and bakers and plumbers and astronomers and geographers and just everything. There was nothing they couldn't do. Nothing. Not like the astrophysicists of today. Compared to back then, it's chalk and cheese. Chalk and cheese. I mean, I'm welling up just reading this. It's emotional stuff. It's powerful. Right. Where are we? Copernicus. One of them states that the planets do move around the sun. Sir Isaac Newton, one of the greatest scientists of all time, followed the teachings of Kepler and discovered why the heavenly bodies do not fall from their places, but through countless centuries have kept to their paths in the sky. It was Newton who worked this out. Newton, with Kepler, just passing the baton. Yeah, run Newton. Thanks, Kepi. I got this. Go, Kepi, go, 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 go. Sir Isaac was the first scientist to explain that every particle of matter in the universe exerts a pull upon every other particle of matter. He called this force gravitation. In the 1600s, the universe, matter, he fucking nailed it, because it's still going today, isn't it? Along with every action has an equal opposite reaction, and the prism, which I should have one coming soon, and you know, the light thing and the gravitation. I mean, Newton. No. No. Newton. Gravitation. The gravitational pull of the Earth holds the moon in the path that it travels around our planet. The gravitational pull of the moon upon the Earth, on the other hand, causes the tides to rise in the oceans of the Earth. And just so the gravitational pull of the sun holds the planets in their paths and keeps them from flying off into space. Yo, come back there, Jupiter. There we go. Slow down a bit. That's right. Kepi. Galileo, Tycho Brahe, Newton. I reckon, just because that's come up right there, 28 minutes already. It's going to be an hour. It's going to be an episode. Now, I just wanted to, just to quickly, right? I was going to do this at the end, right? I hadn't read that book for a long time. I knew it was in there somewhere. I didn't know how it was going to, I couldn't remember exactly how it's going to come, but I think it's a good time to just, you know, I can't zoom in any more than this because it's that zoom thing. Right, folks, just in case you missed an episode, the moon does not move the water on Earth. Here are the main reasons. I think these are valid reasons that even Kepler, Newton even might go, I didn't think of that. Russell. But I did, Newton. I did. there is no pattern. I think that's a big one. There's no pattern. There is no pattern because there is only one moon, right? And all over Earth, do you know how many high tides there are at any one time? How could there be a pattern? How could there be a pattern? The moon, if it's above a high tide, it's purely a coincidence. It shifts every single day. We get 2 high tides here every day. And the moon goes walkabout and then comes back tomorrow. And there's already been 2 high tides. 3 high tides before it gets back here. Do you see where I'm coming from? And then it goes again. It's gone. And we have a low and a high and a low and a high. And sometimes it's here when it's a low. Sometimes it's dropping. Sometimes it's rising. Every now and again, it's a high tide when the moon is here. There is no pattern whatsoever. The 4 highest tides on Earth are so far away from the equator where the moon is orbiting, it would be strange not to it would be strange to not ask the question, why is that happening? Why is it that the moon is orbiting us along the equator, but the Gulf of Mexico, the Mediterranean, they're near the equator, and there's hardly any water movement, the bulge, that's where it would be. See, I think if you don't ask these questions, then what questions would you ever ask? And it just so happens that the moon orbiting has pushed all the water up to the north, and that's where all the high tides are, which is perfectly illogical. Spark, it's illogical, Captain. Thank you. The equator, the lowest. So it's like they have everything back to front, inside out, upside down. It is always. The illogical becomes logical. And the logical is out with the bins in the morning. And I like this one. The tide drops the same direction that it came in from. So the tide comes up for 6 hours, stops 5 minutes to an hour, right? The dead slack tide. And then when it does drop, it goes back the same way it came. But the bulge, no bulge. In, breathe, and out. Not like you would think. So these are valid points. This is a common sense, logic, reasonable, rational thought processes. They all make sense. They really do. The full moon. Now, sun, earth, dark this side, so light that side. Dark, we see the full moon. High tides. It's one of the highest tides. But where is the logic, folks? Where is the logic that the moon is pulling on the water this way and the sun is pulling on the water this side? How on earth is that not going to be one of the lowest tides if those two things were exerting any gravitational pull on Earth's water? It's one of those things where I hate to say this, it doesn't matter what anybody says. If the moon is trying to drag the water this way and the sun is trying to drag the water that way, this is when they would kind of cancel each other out. The moon's slightly more powerful, so we would get a little bit of a... This is where logic has broken down. To think that that position, both of them pulling, would create one of the highest tides. We have the new moon. The moon is there, sun shining onto Earth, so we can't see it, they say. Maybe it's not there, we don't know. We're looking into that at the moment. We have teams looking into that. This is the one where you would expect, because the moon is pulling and the sun is pulling. This is the only one that you would expect really high tides, right? If they were pulling. But I don't know about this bulge at the back. if the moon and the sun are on one side pulling on the water, you'd think she'd kind of bulge there, and it's a little bit stupid. I do believe. Not as stupid as this one, but there are stupidities to be addressed in this one as well. Now, the neap tides. Now, this is another one. So the sun is pulling, the moon was here and it's dropped down. We get the neap tides, some of the lowest tides. This position here, they say that the sun cancels out the moon's gravitational pull. How? They're not working against each other because they're pulling at a right angle, aren't they? Between them. So they're not working against each other, even a single bit. So why would the sun cancel out the moons? Is it the science thing? The science doesn't care about your common sense thing? The universe does not have to make sense to you. This doesn't make sense to me. If the moon is pulling that way and the sun is pulling that way, nothing is going to cancel out. What you would have is a slight bulging here because they're pulling each other, and it would kind of pull it down to there, wouldn't it? Pure logic and common sense. So this one is illogical. That one is illogical. This one is logical if they are pulling, there is a gravitational force, and we get rid of the bulge on that side. Inertia, because of the planet's spin. Yeah, we notice that, don't we? I don't think so. Now, yeah, that will do. So I will have a little bit of a coffee break and come back with the rest of this fantastic story. Welcome back, fuckers. Welcome back. So that up there, it's just loads of little tiny magnets, right? Tick, 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 the little round magnets, okay? And then I put those two there. They're all individual magnets, so that's pointing north, right? That's pointing north. And then I have my two, I love these two powerful ones, right? So I'll put that here, just to mess with this, so you have entertainment, right? Sometimes it just carries on spinning and, you know. But it won't do that. Ah, there we go, see? Right. You might get a little kick out of it. It's just a bit of entertainment in the background. Now, where were we? And just so the gravitational pull of the sun holds the planets in their paths and keeps them from flying off into space. Come back, Jupiter. There we go. Slow down. Gravity. But we know that the moon, no. This stuff, there's no logic in any of it. No logic in any of it. The laws of planetary motion and gravitation still hold true. In the years that have passed, astronomers have constantly made new discoveries about the various members of the solar system. They have never found any evidence, however, to contradict the results of the superb work done by those two scientific geniuses, Kepler and Newton, who set down the laws of planetary motion and the laws of gravitation. I would like to put my hand up and call those out, because it is wrong. It's wrong. It's ridiculous. It's a joke. It's an insult to humanity's intelligence, is what it is. See, I get worked up because it's annoying that these people, this is so stupid. It was not until all the groundwork done by Copernicus, Galileo, Kepler, Newton and many others was finished that astronomers could begin to work out intelligent theories about the birth of the Earth and the origin of the solar system. Any theory to be at all satisfactory must conform to the known laws of how the planets behave. Certain similarities in the behavior of the planets are very striking. Let us examine some of the likenesses, for they must all be taken into account in the making of a theory about the planets. Newton. Number one, all of the planets move in the same direction around the sun. Number two, they move in very nearly the same plane. To understand just what this means, look, we'll play. No, let's look. We're here. To understand just what this means, let us compare a merry-go-round and a roller coaster. In the merry-go-round, the horses all move around the center on one level or in one plane. On the roller coaster, the tracks go up and down, and the cars that travel on them do not travel in one plane. A line drawn between any two or more points on a plane will lie entirely within that surface. If the tracks of the roller coaster were all laid out on a flat surface, but of course it would then no longer be a roller coaster, would it? They're so clever, aren't they? The cars will travel in one plane. Number three, the planets move in very nearly circular paths around the sun. In actual fact, these paths are slightly elliptical. Good save, 1961. Good save, or oval, but not very far removed from the circular form. Number four, the solar system forms a little family by itself in space, since its members are somewhat clustered together. Yes, we are clustered together. I suppose it depends what you're comparing it with. If you're comparing it with, let's say, a bowl of apples, now that's clustered together, isn't it? So, kind of relative, isn't it, that one? Clustered together. The sun spins or rotates on its axis in the same direction as that in which the planets revolve around it. The planets too rotate in the same direction as that in which they revolve. Most of the 30 moons in the solar system, although not all of them travel around their primaries, in brackets the planets to which they belong, close brackets, in that same direction also. 7. The planets are located at more or less regular distances from each other. Well, we've got Mercury, and there's only, I don't know, was it 30, 40 to Venus, 15 million to Earth, and then 200, depending where we are in our orbits, to Mars. It's 3 minutes light to get from Sun to Mercury, isn't it? And then another 3 to Venus, another 2 to Earth, then another 5 to 6 to Mars, then 3/4 of an hour to Jupiter, and then it gets a little bit silly. So, same planets are more or less regular distances from each other. Maybe in 1961 they would have thought that, but now we know that to be not true, right? Each planet with its own, so number 8, each planet with its own moons forms a kind of miniature solar system that bears some resemblance to the solar system of which the planets themselves are a part. Scientists believe that because the planets behave alike in so many respects, they must all have been formed more or less at the same time and in the same manner. After all, if the various planets were formed at different times and in different ways, we should not expect them to behave so much alike or to follow an orderly pattern as they do. So what they're saying is, us lot, Pluto, down to us, to Mercury, to the Sun, we all behave in such a manner that would suggest that, boom, we all come out together. I'm crying, a couple of twins, not twins, but can't say that. Can't say that. Especially knowing that gravity is just not what they say it is. I mean, this is just horseradish. It's just a story. It's fiction. It's a once upon a time. It's a once upon a time. It really is. Therefore, any theory about the birth of the Earth takes the common origin of the planets for granted. After examining the facts about the planets and keeping in mind the orderly arrangement and working of the solar system as a whole, the astronomer is ready to work out his own theory as to the origin of the solar system and of the Earth itself. Look. It's all wrong. It's all wrong. Of course it's all wrong. We know for a fact that the moon is not budging the water. So straight away, what is moving the water? What is moving the water? If it isn't the moon doing that, which it isn't, one has to really ask themselves, 1/6 of Earth's gravitational pull on the moon. But the moon is not, so why would anybody think there is even any gravity? Even here, it could be about buoyancy and density, because gravity is not shifting any of the water. And if it was, some of the other bodies of water, you would expect some of them, but no. They have been. The studies been done, but it's so tiny, you know, the ocean, the Atlantic, the Pacific, but the Caspian Sea, no, we're good. No, we're good. Nothing. The Black Sea, nothing. The Great Lakes in America, nothing. Not even a pipsqueak. Mediterranean, that's where I grew up. Tiny tides. Gulf of Mexico, tiny tides near the equator. But up north, the 4 highest tides on Earth. Long way. 60 degrees away from the equator. Yeah. 60 degrees north of the equator. That's where the high tides are. Where, far from where the moon is, far. In 1755, Immanuel Kant, the German philosopher, suggested that the solar system, the sun, the planets, the moons, of which there are 30, I think you'll find there's over 100 and something now, the asteroids, the comets, and the meteors was formed from a nebula. There are many nebulae, great masses of thin and veil-like gas scattered throughout the universe. Brackets. You may be familiar with the great nebula in the constellation Orion, which is just visible to the naked eye on a clear winter's night. Close brackets. Everybody must know. You go outside, don't tell me you don't know how to go. Right, there's the nebula. Everybody knows that. You must be familiar with it. Kant's theory, however, did not cause much of a stir in the scientific world. Same as you guys didn't stir when I said you must know. Same kind of a thing for hundreds of years. Nobody cared. The great French naturalist Georges Louis Leclerc, Comte de Buffon, wrote in this same general period his own answer to the question as to how the Earth was born. Oh, this will be good. Buffon was the author of a very famous work on natural history in 44 volumes. What was it? 1755. 44 volumes. It's amazing stuff. It was in this great work that Buffon gave his theory of the origin of the Earth and other planets. He believed that ages ago the sun collided with another heavenly body, which he called a comet. Actually, what he probably meant was not a comet, but another star. So, thanks for correcting Buffon from a few hundred years ago. He didn't mean a comet, even though he said a comet, but somebody reckons he meant not a comet, a star, even though he said a comet. It's good that people are correcting other people's work hundreds of years later. He believed that ages ago the sun collided with a comet. Actually, what he probably meant was not a comet, but another star. Brackets. Rather little was known at the time about the nature of comets. Okay, close brackets. He suggested that such a collision would force a great deal of material out of the sun, boom, and that this material would cool and become the planets. When we later examine theories that were widely accepted during the first half of the 20th century, we shall see how very modern Buffon's idea concerning the formation of the planets proved to be. And they always do that, don't they? And considering the instruments he had, to get to within 10% of the speed of light was an amazing feat, isn't it? They're always doing that. And he couldn't have known that he was going to be less than 5% away from the final figure. They always do it. These patterns, they're pathetic. Pathetic. Sorry if I'm being facetious, Simon Dan, but I can't help it, mate. This stuff is ridiculous. Children should know that. Where are we? Concerning the formation, right? Pierre-Simon Marquis de Laplace, 1749 to 1847, a French mathematical astronomer, rejected Buffon's theory and offered his own. This was the first one to be widely accepted. Laplace's ideas about the birth of the Earth and the solar system are set forth in his nebula hypothesis, a clever theory that won wide attention in the 1700 and something. Wide attention from where? From the couple of streets where he used to live, or the delivery trucks were out pumping the books out everywhere. Yo, still a place, look. And everybody's like, oh, there was a massive reaction because the science community was in awe of Laplace's bullshit. It's just, cannot people read into these things? It's just so stupid. It really is. It's an insult to everybody's intelligence. Anyway, this was the first one to be widely accepted. Laplace's ideas about a clever theory that won wide attention. In brackets, a hypothesis is a scientific theory that is based on observed facts of all sorts, or at least does not contradict them. I mean, maybe it's just all a joke. Is there a little thing that says, got ya? It must be. It's ridiculous. The nebula hypothesis imagines first a tremendous explosion of a star that, according to Laplace, later became the center of the solar system. Exploding stars, which are not at all uncommon. They're not at all uncommon. I have been here for a fair few decades and I've never seen one. Never heard of, not in my time. So when they say they're not uncommon, what do they mean by not uncommon? Not uncommon in history where nobody can verify that they were not uncommon? Or uncommon in the sense that can you see what I'm saying? They're not uncommon. Which exploding stars, which are not at all uncommon, are known as nova or new stars. I think they're uncommon. I don't think they're very common at all. I've never seen one. Never seen one. So, do we have footage? Oh, it's one of those. Back in the past with the telescopes. Oh, that footage you mean? No, I mean actual footage. Footage, real stuff. No, not the telescope stuff looking into the past. I mean real footage, actual footage. See, we can keep going around in circles on that one. Just like the moon does and the sun does around the flat earth. Just keep going round. I am being facetious now. I'm sorry. I don't mean to be, okay? It just... This name was given them originally because when a faint star exploded and became suddenly very much more brilliant than it had been before, it was often mistaken for a new star in the heavens. Often. So, bang, look, oh, there's one, yeah, and boom, look. They were not uncommon, but only now, in our time, they've become not common at all, very uncommon. In fact, non-existent. But back then, it was a thing. It says here, as a result of Laplace's explosion, the hypothesis suggests the sun expanded until the vast fire mist of which it was made extended out in a giant nebula beyond the orbit of the outermost planet to be. In other words, all of the future members of the solar family were then part of an enormous whirling mist of incandescent gases. In the beginning, they had no form and no individuality, but were blended in the parent nebulous mass. Laplace, of course, lived long before the discovery of the ninth planet, Pluto. Even Neptune had been discovered just the year before he died. There's a lot of that as well. And he died the year before. And he just died just as his discovery was. And unfortunately, the day after, he died. It always happens. Always. Not always. It's very common, right? It's not uncommon for them to die close to an event that they had something to do with. And they don't really find out before they kick the bucket, which is a shame. The diameter of the nebula must have been, if Laplace was correct, over 4,000 times the present diameter, 864,000 kilometers. Sun. we're nearly done. 1961. This is what happened. I bet you there'll be some changes nowadays. Things like the Sagnac effect and the Schwarzkopf effect. See, none of these books, none of the encyclopedias I have, up to the 1990s, and then other physics, science stuff, books, nothing. Not in any of the books. But it's on the digital, the hand is faster than the mouse. Oh, where did that come from? Who? Sagnac effect. Oh, well, it's been going. It's linked in with relativity and Einstein, so it must be a thing. Ow! Even though it's in none of the books. Look, folks. Look. Right, where are we? Laplace thought that the planets were formed from rings of gas. The enormous nebulous mist of gas, according to the hypothesis, cooled and contracted. As it contracted, it spun faster and faster, according to a well-known law. Kepler's, one of Kepler's laws, must be true. Now, if we twirl a wet mop faster and faster, the water begins to fly off. It does. It was Laplace's idea that as the fine mist rotated, it flung off, in somewhat the same manner, great rings of gas. The rings spun for a time, but at last broke and collected into big rotating balls of gas. That's us. I like it. These, in their turn, eventually cooled and contracted to form the more or less solid planets. The first ball from the first ring thrown off would be the planet farthest out in the system. Pluto! Go, go, go! Oh, slow it down. So, whoa. That's it. Just orbit me now. That's it. This is what happened, okay? The ring spun for the first ball from the first ring thrown off would be the planet farthest out in the system, which Laplace thought was Neptune, because they didn't know about Pluto back then. As the nebula contracted more and more and spun ever faster and faster, other rings would form, contracting into other planets. Jupiter, Mars, like the sun really went into one. One of these, of course, must have been Earth. Hang on, mate. Right, okay, where are we? And I hate it when I do this. Right, there we are. One of these, of course, must have been the Earth. The Earth continued its spinning, its cooling and contracting. In time, as it contracted, it threw off, according to the theory, the body we know as the moon. So the sun slings us off, and then we kind of, I don't know, back here, son, yeah. And then we go, and we sling off a moon. It's good, isn't it? It's good. I like it. I like it a lot. This is what we've got. This is all we have. Unbelievable. In time, as it contracted, it threw off, according to the theory, the body we now know as the moon. The trouble with Laplace's theory is that we now know that the rotating mass of nebulous gas would not throw off rings, even if, by some strange chance, rings were formed, they would never come together to form the planets, but would break up into a great many small gaseous fragments. In time, these fragments of nebulous material would be dissipated and disappear into space. Of course, you must have known that. You must have known that when they were talking about the planets flying off and the Earth fucking slinging the moon out, you must have known that was horseradish, because that wouldn't have happened. It wouldn't have happened. Hang on. It wouldn't have happened, folks. I think he's having a laugh. I think he's having a laugh now. Right. There is another difficulty with Laplace's hypothesis. Not another difficulty. If the solar system really did form in the way he thought it did, the mass, coming to the end, the mass of gas that formed the sun, the central part of the original nebula, would spin much faster than any of the planets formed from it. And this is not true. It's not true. The sun spins more slowly than most of the planets. Not all of the planets. While the Places nebula hypothesis is very clever, it does not account for many of the facts we observe about the solar system. It was accepted, however, for many years, and generations of school children were taught that the parent of the solar system was undoubtedly a nebula. But now they're taught that the children of today are taught that on a spinning globe, all the water, right, spinning on an axis about 1,000 and something miles at the equator, at the same time as we're orbiting the sun. I think it's 66,000 kilometers or miles per hour. I get giddy. And all of this, and there's no curvature, and we don't move. What's worse, what they were taught back then, or the horseradish being taught now? There's no movement. There's no movement. Nothing. Look at those things. Very sensitive. You know, if there was a bit of chocking and changing, sun's flying over and shit. I mean, the one that collides, not our one. It's the way they say it as well. It's the way they say it. For many years, and generations of school children were taught that the parent of the solar system was undoubtedly a nebula. As if to say, but now the school children, they're taught correctly, aren't they? Newton. There was no widely accepted theory about the formation of the solar system to take the place of the places. I like it. They got it. They nailed it. There was no widely accepted theory about the formation of the solar system to take the place of Laplace. I like it. Until the beginning of the 20th century, about 1900. Can I feel Einstein coming down the tracks? The astronomer Forrest Ray Moulton and the geologist T.C. Chamberlain of the University of Chicago, here we go, the boys are in, presented to the world of science a new theory, the planetesimal hypothesis. In brackets, planetesimal means tiny planet or very small heavenly body, period, close bracket. I thought it should have been close bracket in the period after. That's what, okay. As you already know, the sun is a star that appears bigger and brighter to us than the other stars because it is so much closer to the Earth than any of the other stars. Were we aware of this, folks? The reason that we see the sun so big is because it is... Hang on, mate. You think it's a joke? Okay, an hour and 2 minutes. Woo. Right. As you already know, the sun is a star that appears bigger and brighter to us than the other stars because it is so much closer to the Earth than any of the others. I am going to agree. Whether the others are stars or not, they got this right. Damn. You! Tick. You see that tick? I give him a tick. Right? So don't say that I'm picking on them. There you go. The reason the sun, we see it so big and so bright, is because it is closer than all of the other stars. There is hope. There is hope. All the stars travel very rapidly through space, many miles a second. The planetesimal hypothesis suggests that 2 or 3 billion years ago, a star speeding through space came very close to our sun. Perhaps this visiting star just avoided a collision with the sun, or perhaps it even accidentally, boom, collided with the sun. Planetesimal hypothesis. I like it so far. While we never worry much about the sun's colliding with another star, such a collision could happen, of course. But the space between the stars is so great that collisions could not happen often enough to cause us alarm. So what they're saying is they're uncommon. It's not a very common event. Like the nova are common, but a star hitting the sun, that is very uncommon, especially if there is a firmament. But I'm being objective. Maybe there isn't. But either way, a star come flying towards our sun and hitting it. It's not something that happens every other weekend. Okay, that's all they're saying. Where are we? Perhaps this visiting star just avoided a collision. While we never worry much about the sun's colliding with another star, such a collision could happen, of course, but the space between the stars is so great. We know that if such a collision occurred, the gravitational attraction of the passing star would have pulled out great masses of gas from the sun. Which brings me back to the moon and the sun and the water. Now, see, it's talking about gravitational pull. Now, I don't know if people were paying attention to what I said before, but folks, it is a slam dunk. This stuff is an insult to people's intelligence everywhere. No pattern. The 4 highest tides couldn't be fucking further away from the equator. They could not be, well, they could be at the North Pole. You know what I mean? Look at this. At the equator, where the moon is orbiting, it's the lowest. There's hardly any action. The tide comes up, hour, and then drops back the same way. How is that the moon spinning around a spinning planet? It isn't, folks. It is not. It's just not. It's wrong. We know that, right, massive gas. We know that if such a collision occurred, the gravitational attraction of the passing star would have pulled out great masses of gas from the sun. In the same way, the sun's pull would have acted on the other star. In other words, each star would have raised great tides in the hot gaseous body of the other. In much the same way, the pull of the moon raises tides in the oceans and even in the more or less solid body of Earth. But folks, it does not. It does not. Now it doesn't matter what anybody else says. If you cannot see the common sense and logic in what I'm saying, and you believe that when the moon is on that side and the sun is that side and Earth is in between, that somehow those pulling us apart is going to create the highest tides, where it wouldn't, because they would counter each other out here. And do we need to go on? That is wrong, I hope. It would be shocking if people were saying, what are you talking about, mate? It's obvious that there's going to be a massive tide on this one, and look, can only do what we can do. But it's wrong. It's not wrong. They know it's wrong. It's illogical and an insult to people's intelligence wrong. That is the problem. That is the problem, right? Right. As the tides caused by the pull of the passing star became greater and greater, masses of gas must have been thrown clear of the sun's main mass. They would have whirled around and around, some of them following the other star as it dashed off into space, and some of them held by the attraction of the sun, starting to move around that body. So the sun comes, the star comes close to the sun, and they just sucked up in the vacuum, and there's flames everywhere, and our sun throws the fucking kick that, and it's throwing it, and there's fire chasing that sun that's going, and the sun here is getting bombarded by the other sun's crap and all the chaos. I like it as a theory. It's good. It's compelling. Truly compelling. They would have whirled around and around, some of them following the other star as it dashed off another. As the great tide subsided with the moving on of the other star, the masses of gas which were to become the planets settled down into their orderly paths around the sun. As they became cooler, they probably changed into liquid form and then gradually became small, solid, cube masses like Pluto. I like it. These small bits of matter, planetesimals, eventually drew together to form planets. If this theory is correct, the meteors of our solar system and possibly the asteroids, in brackets minor planets, are probably the planetesimals that were left over and that never took part in the formation of the major planets. So they fucking skedaddled. All the chaos, the sun and the flames and the woof, And they thought, fuck this, and they've gone. Everything's sorted itself out, and they've come back. Oh, looks all right now. It's a bit off, isn't it? But it's a really good theory, I like it. All the way through. Sir James Jeans and H. Jeffreys, two English scientists, worked out a variation of the encounter or collision theory, which is called the tidal theory. We're nearly finished, right? These scientists differed from Moulton and Chamberlain in that they did not believe the planets were formed from great numbers of small bodies or planetesimals. Their idea was that the planets were formed from original great masses of gas pulled out of the sun by the passing star, and not by the building up of great solid bodies from small particles. The same process of cooling, liquefying, and then becoming solid would, however, have taken place. So we still have a rogue star just fucking thinks it can come into our neighborhood and hound our star. It's here written, folks, right? There's two theories. One of them has to be correct. Has to be correct. The tidal theory suggests that as the passing star approached, or even sideswiped our sun, its gravitational pull, you've got to weigh these things up here, okay? Gravitational pull drew out from opposite sides of the sun, our sun, two long cigar-shaped masses of gas. Well, let's try and picture this. We have to try and picture this. Otherwise, it's just not cricket, is it? Now, so what we have is, we have our sun minding its own business, right? Before the stuff is just starting up. Our sun is here, just cruising about, just working out where to fucking put roots down. And this other sun comes flying out of nowhere, right? You don't even see it. And our sun shoots two cigar-shaped things, right? Hang on. Two long cigar-shaped masses of gas. These filaments must have been largest in the middle section and tapering at both ends, much like a cigar. Right? So you could picture this happening. This other one's gone. It caused the chaos. Could have fucking destroyed our sun altogether. So we've got two cigars now, and that is a good call. If something like this happens, you know that our sun's going to shoot two cigar-shaped things out. The theory suggests that the smaller planets, which we find among those closest to the sun and those farthest from it, may have been formed from the smaller ends, and the larger planets from the larger middle part. So look, we've got Pluto, Mercury, Venus, and then we've got Jupiter and Neptune, and then Earth and Mars, and that kind of thing. Look, you tell me that's not feasible. I mean, the other side, if it had been a direct hit, we wouldn't be formed yet. We'd still be doing the gravity thing and trying to sort ourselves out. I'm getting emotional thinking about it. Jeffreys differed somewhat from Jeans in thinking that the encounter between the two stars may have been an actual head-on collision. See, if it had been a head-on, this is the thing, see? You've got to then put yourself in the position of our star, right? So our star, if he thinks it was a head-on collision, right? You've got our stars just cruising, looking for a place, and then another star comes and collides. It hits our star. Look, it's not going to be traveling at 60, 70 k's an hour. These things move very fast. Guys, there's nothing left. There's nothing left. So, another idiot, another lie. These things are so stupid if you listen and process the information and play out the things that they're saying. It's in everything. It's in everything. It really is. But I do like this theory. I think it's more the head-on collision. I can't see the cigar shape. I can see loads of planets coming out of it, but it will take a lot longer to sort itself out, I do believe. While the various forms of the encounter or collision theory could explain many of the ways in which the bodies of the solar system behave, there are certain important observed facts about the solar system that come to the end but they do not explain in a satisfactory manner. I don't think they explain absolutely fucking anything in a satisfactory manner. In fact, anybody who thinks that anything they've heard today is somehow in a satisfactory manner, that would be part of the problem, folks, okay? The theory is now, therefore, regarded with some suspicion by astronomers. I rest my case. I rest my case. The same difficulty is found here as that which was noted in the case of the nebula hypothesis. The encounter theories do not account for the fact that the sun spins more slowly than most of the planets. Light that matters. Light that matters. Is that why the nebula hypothesis? Oh look, see how fast that sun is going. Not nebula. It can't be. Look at it's too slow. It would be spinning faster. It's just, it's this insult. These people are making out they're way more intelligent than they really are, but they're not, because it's just so unbelievable. That's the worst bit about this, folks. It's so unbelievable. It's because people don't focus on the details of what is written. They just speed read it. Oh yeah, that's cool, that's cool, that's cool. Newton, love it. That's not the way to do these things. It's all here. It's all right here. It's like a horseradish express. According to one theory, the sun, it's the last one, was originally a double star. Can we do this? It's the last one. Another modification of the planetesimal hypothesis suggests that the sun may have been originally a double star, with two suns moving around a common centre of gravity. There are many such stars in the sky known to astronomers today. Indeed, double stars are very common. I mean, we've got Proxima Centauri, haven't we? Proxima B, Proxima A, I should have said Proxima A, Proxima B, like that. They're, spinning around together. Yeah, it's a common thing. Not that common that we see them every day, but we're told that. But if there is a firmament, they're not so common, are they? But we don't know that yet, do we? But what we do know, there are many such. Indeed, double stars are very common. The astronomer R.A. Littleton suggests that the passing star may have struck not the sun, but the companion star of the sun. So we're back there again. So now what we have, not a single sun, there's a couple of them. They're probably talking, chatting, having a great time, looking where to settle down. Where should we go? Says one son to the other. I don't know. What about over there? That looks nice. I think I could settle down here. Yes, said the other son, as it orbited, they're having some fun. And then out of nowhere, boom! And this other sun just freaking wipes one of them out. Not our sun, the other sun. That's what's happened here. Listen. In some ways, it suggests that the passing star may have struck not the sun, but the companion star of the sun. In some ways, this theory gives a better explanation of the solar system than do the other forms of the collision theory. So this one is feasible. They like this one. Can we imagine? Let's have a think. Bang! Yeah, I can see it right now. Boom, Mercury, Venus, Earth, Mars, Jupiter, Saturn. They're all there. Can you play that out in your head? Just kind of boom. The way it glances off, it just perfect spin. And then this sun is left. Sad, but it's got planets now. It was a loss, but a gain. It lost 1, but gained 9. And if there is 10 Nibiru, so every cloud. Another suggestion is that the sun and planets were formed from a vast rotating dust cloud in the sky. Of one thing we can be certain, however, and this was mentioned earlier, the Earth is a member of a family, right? The sun's family, and the other planets must have been born at the same time as our own planet. So, right? It's here. And Newton probably had some input here, I'd say. Right. The similarities of the planet's behaviour make this clear. Because the behaviour of planets, and they look alike, don't they? Mercury, rock, Venus, toxic Earth, water. What's a water planet? Then Mars, red. So far, they're all very similar. And then we have Jupiter. I don't know. Doesn't look like Earth or some of the smaller ones. Saturn. Well, the rings. It's not. Uranus. Neptune. Pluto. Similarities. The similarities of the planets' behaviour makes this clear. The behaviour, like the orbiting and stuff. Yeah. Perhaps you have wondered about the manner in which the moons of the planets came into being. Yes, every fucking morning. As soon as I wake up, all I think about. Some astronomers believe that the Earth's moon may have been formed at the same time and in the same way as that in which the Earth itself was formed, from a ball of gas pulled out of the sun by the passing star. According to this theory, the moon must have been captured by the pull of the Earth upon it. Like a sun, yo, moon, and we fucking, this sun that come out of nowhere. It's bad, it's bad. Of course, it is possible that the other moons in the solar system belonging to other planets could have been formed in this same way. Look, I'm open to everything apart from this bullshit. Anything but this. Other astronomers believe that the moon may have been pulled out of the massive gas that had already begun to form in the shape of the Earth. Some astronomers have even suggested that the moon may have been pulled out of the Earth to form the great hole that contains the Pacific Ocean today. So Earth just went, boom, get back there, Pacific. That's what they're saying. Perfectly feasible. At least it's not a collision with another sun, is it? Nearly done. One of the most interesting problems concerning the satellites or moons of the solar system has to do with the retrograde satellites, those that revolve around their primaries in a direction opposite to the usual direction in their solar system. Several of Jupiter's moons, for instance, behave in this peculiar way. It would seem that the backward moving satellites could not have been formed with the other members of the solar system, since they do not share the common direction of motion. Perhaps, who knows, they may have been asteroids captured later by the great planet when they passed close to it in their travels around the sun. The initial boomba and those ones fricked off, remember? And they come back later. And the Jupiters, the big ones, allow them back, but spinning the opposite way. Splitter, and everybody else is, so they always know who the ones split at the beginning. Like that. Wankers. Yeah, I like it. Is our solar system the only one in all the universe? This is it. As you can see, there are many problems in connection with our solar system the astronomers have not yet solved. There is another question, however, that we might call the $1 million question. Now, this was 1961, so we're looking at 500 billion, probably now, $1 million question. Is our solar system the only one in all the universe? In the old days, astronomers did not consider seriously the possibility that there might be other worlds than those we know in our own solar system. Today, there are many astronomers who believe that there must be millions of solar systems like our own. Some believe that it is more possible than not that other stars have planets moving around them and dodging other stars, and we don't want another collision like we had down here. Some believe that it is more possible than not that other stars have planets moving around them. Other firmaments? Other gods, maybe. Who knows where this ends and where it begins? We could, of course, be sure about this if we knew just how our own Earth and its brother and sister planets were formed. Well, what a morning. God, I hope that's a wrap. I'm not doing that again. If it's not a wrap, you'll never know, because I just 124. Folks, when I can get this done in the next 6 minutes, when I was going down Burnett Heads, and I had this thing with all the rocks and stuff, right? And I found all of this stuff. Found some crazy stuff, right? Now this one here, there's loads of these, right? Now they look like tools. They look like they fit, right? They fit. Now this little dancer here, it's a bit special. I can't zoom out, can I? I can't. So the reason I put this up here on top of books and a container, because this metal detector here is very sensitive, okay? Right, I'm going to push you back because you need to see all of this. Right, and we are rolling. So I always check my stones for magnetism, right? Because you get them. Now look at this, right? Right, no gimmicks. Oh. I knocked that back so I thought it was going over. Oh, those magnets don't do it because they're magnets, but this is not a magnet. I gave up online. People are like, how big is it? What does it look like? Couldn't post a picture for some reason. No, I think you're lying. Oh, that's because of that one. There is so much stuff down where I live. It's unbelievable, the amount of stuff, of rocks, that clearly shows that we're being told next to nothing of what's true. They've rewritten everything as they please. Everything. Including Newton. Newton! It's a myth. It's a myth. 1:28. Folks, there's no sun today. Right, but what I did yesterday, there can be no sun above Norway's horizon at the same time as we're seeing the sun in our horizon. Both of us northeasterly horizon. It's not possible. It is not possible because we're looking like that. We're not looking like that, parallel. The moon, I'm hoping, another piggyback. I just have to keep coming back until people understand that I'm not talking rubbish, right? There's massive changes happening all over the planet, right? Gravity. Look, I'll do that one later because I wanted to stop this. There was something else I wanted to add, but as you can see, I got sidetracked. Right, folks, it's been emotional. I will be back. Laters.